What's up, everyone? This is LeetCode 207 course schedule. So we're given an input called num courses, and these are the total number of courses we have to take. And basically, we go from 0 up to and including num courses minus 1. So if num courses is 2, we basically have 2 courses we can take, right? Course 0 and course 1. Yeah, that's what this is telling you. And then we're also given an input called prerequisites, where it's structured like this, where you have a pair, right? A1 and B1. And it indicates that in order to take course B1, you first must take, you must take course B1 first before you can take course A1, right? So B1 is like the prerequisite to the course A1. So in this pair here, right, B1 would be 1, so that would be the prerequisite to take course 0. So we have to take course 1 before we can take course 0, right? Indicates that you have to take course 0 for this indicates that to take course 0, you first have to take course 1, okay? And we basically have to return true if we can finish all the courses, otherwise return false. So we're going to go through some examples now. I think this problem is a lot easier to understand if you look at it visually first before you write any code. So this is example 1, right? We have to take course 0 before we can take course 1, right? So it looks something like this, right? In order to take course 1, we have to take course 0 first. Okay, pretty simple. Example 2 is a little bit different, right? In order to take course 0, we have to take, in order to take course 1, we have to take course 0, but in order to take course 0, we have to take course 1, right? So we have something like this, right? To take 0, we need to take course 1, but to take course 1, we need to take course 0. So we have like a cycle, right? Like, how are we ever going to, like, we can't start anywhere, right? And so this would be an example where you would return false because you cannot finish all the courses, right? So really this is kind of like the simplified version of what would be problematic in an input, right? Is when you have a cycle like this. Because you can't actually complete all the courses in that case, right? Here, for example, would be an okay example. But let's say this 3 went here. Then all of a sudden we have a cycle, right? Because we need to take course 3, we need to take course 2, but to take course 2, we need to take course 3. So if we had like a cycle right here, that would not be great. But this works fine, right? Because we don't have a cycle anywhere, right? To take course 3, right, we can take these two. To take either of these two, we can take course 0, right? So, so how are we going to solve this? So we're going to use a hash map, okay? That's how we're going to solve it. And we're going to build out an adjacency list where basically the key is the node that for a particular course, and the value is the prerequisites for the course, right? So for example, this example here is for example 3, right? So for example, to take course 0, we have no prerequisites, right? I mean, we have nothing over here. So it's empty, right? Now the adjacency list for course 1 would be course 0, right? Now, I know in a lot of times the adjacency list is like for neighbors, so technically like maybe 1 should point to 3, not to 0, but when I say adjacency list, I'm not referring necessarily to neighbors, I'm referring to the prerequisite, right? So this is how it would be structured. Right, to take course 1, we have a prerequisite of course 0 first, right? To take course 2, we have a prerequisite of course 0 as well. To take course 3, we have a prerequisite of 1 and 2, okay? And I basically wrote out these steps here in terms of just to kind of break down how we're going to handle this, right? We're going to set up the adjacency list, right, or the hash map first, right? Second of all, we're going to create two sets, right? One is a visited set and one is a process set. And the point of that is that, like, we want to basically have like a visited set and a process set, because we're gonna start. We're gonna basically go from 0 up to num courses minus 1, right? Like it said up here, right? Because that's how many num courses we actually have. So the way we're going to do this is that we're going to process a specific node, right? And we're going to see, can we actually take that? And do we have any like problems. So for example, we start at the 0 and we'd put that in as a visited set, right? And from there onwards, we would basically go into the hash map and check the prerequisites for that node, right? In this case, it'd be empty. So we wouldn't have a problem, right? And so we'd be done checking this. So we'd remove 0 from visited and put it into the processed. And the point of using a process set is that, like, for example, let's say we process this node and we don't have any problems checking all the prerequisites. There's no cycle or anything. When we're at this 3, we have to check this 2 and this 1, right? But when we check this 1, if it's in processed already, we can just skip this. We don't have to do anything. Basically, the visited set is for processing a node, right? And kind of doing like a depth first search or a topological sort. When we're done with that, if we don't have any problems, we put it into the process set. Now, when we're at this 3, before we get to this 3, we have to handle this 1, right? So the point of the process set is, like, when we're at this 3 and we check the prerequisites, we have 2 and 1. Well, if we already handled this 1, do we really want to run a depth first search or a topological sort to check if we can actually take this course? No, it's pointless, right? Because we already did that previously. That's kind of the point of the process set, is to basically cut down on redundancy. And then the visited set is to actually do the checking on a node, right? So for example, and let me not use this example, let's do a simpler example, right? We have like a 0, 1. Okay. Now let's say we're at this 2, right? Like we process this. So when we're at this 2, we're gonna basically put that in our visited set, and we're going to basically go into the, I guess it would be different. Let's say like we have our key here, our values here, right? We have 0, 1, 2, whatever. And for 2, the prerequisite would be 1. Okay. So when we're at this 2, we're basically going to do a DFS. So we'd go into the 1, right? When we go into the 1, check the prerequisites of that, etc. But we're not actually going to do that like every single, like when you think about like the stack and the recursion, we're not actually doing that every single time because we're using the processed set. That's kind of the point of it. So for example, when we're at this 1, we check the prerequisites of that. Do we have a problem? No. Okay. So when we're done processing this 1, we put this into the process set. So when we're at this 2 and we check the prerequisites, we check this 1, right? And it's already in the process set, so we can actually just return true because we know for sure it should work, right? Because if this 1, when we check it the first time, not going from 2 to 1, but when we check this 1 by itself, right before we even get to the 2, if we have a problem, we'll just exit the code anyways, or the loop, right? So that's why we have a visited set and a process set. I hope that explanation's okay, but if you're confused, like it might a little bit, I would stick around. It might make a little bit more sense when you see the code. Okay, so we're going to do DFS on the graph to see if we can take all courses, right? And then by DFS, really, we're just doing a topological sort to detect a cycle. Although I guess it's kind of like a reverse topological sort. But yeah. Okay, so the way we're going to do this, okay, is first of all, we have to handle an edge case, which is going to be, if we don't have any prerequisites, then just return true, because we can take all courses, right? Okay, now here is step 1, right? Which is we're gonna have to build the adjacency list or the hash map, right? But before we do that, let's create our sets, right? So we have a visited set, like I said, and we have a processed set, like I said. And we also have a course graph, picked, list. Okay, so let's basically build out our adjacency list, which again is not, when I say adjacency list, we're not using the neighbors of a particular node, we're using the prerequisites, okay, for the graph. So just keep that in mind. So we're gonna say for course prereq in requisites the course is going to be the key, remember, and the prerequisites are going to be the oops, the prerequisites are going to be the actual value in the hash map. Okay, done. So we set up our adjacency list so far, right? Like this. Now we already created the visited set and stuff. Now we need to actually implement the DFS of how we're going to do this, okay? So we're going to obviously have a DFS function when we have a course, right? Now, when we're handling a particular course, we're going to have two potential outcomes, right? So we first have to check if the course we are on already has been visited, right? Because let me just go create an example. So let's say we have a 0 and a 1, right? Let's say we start at the 0, right? Does this 0 have any prerequisites? Yes, it has a 1. Well, initially we would start by having a visited set. We would add the 0 because that's where we start, right? Now, does this 0 have a prerequisite? Yes, it has a prerequisite of 1. Okay. Now, does this 1 have a prerequisite? Again, we're doing a DFS, right? So we have to keep going. Does this 1 have a prerequisite? Yes, it has a prerequisite of 0. Well, 0's already in our visited set, right? And we encountered the 0 again. So that basically lets us know that we have a cycle, right? Like if we're on a particular course and it's already in the visited set, we have a problem, right? So we're gonna say if course in visited, we return false, right? Because that's a problem. Now, check in the second case, we would check if the course we are on has already been processed. Not I'm gonna explain the process part again, just so you're not confused, right? The point of the process node is that, like, okay, we have a visited set and we have a process set, right? Now this 0 has no prerequisites, so initially we put it in, but when we're done, it has no prerequisites. We're done with it, so we remove it from the visited set and put it in the process set. So, because we didn't run into any issues, right? So when we go over to this 1, which is the next node, right? Okay, does this have any prerequisites? Yes, it has a 0. So when we go in the stack, in our recursion, when we get to this 0 node, right? It's already in the process node, so we already know we're not going to run into any issues with any of the prerequisites for 0. So we can basically just return true because we don't need to check anything about its prerequisites because we already handled that beforehand, right? So it's really I don't know if I'd call it memoization necessarily, like in terms of DP, but it's just cutting down on redundancy, right? That's what we're doing. This basically makes it so that we already processed a node, so why process it a second time? It's not necessary, right? So this would be a case where basically if course in processed, just return true, right? We don't want to process it twice. That makes no sense, right? This is to skip redundant work since we know we can fulfill its prerequisites already. Okay, pretty simple. Now this is the part where we actually have to add it into the visited set, right? Because I mean, when we initially start off on a node, obviously it's not going to be in visited because it's our first go around, so we're not going to detect the cycle right away. But then we add it to the visited set, and basically we keep expanding from its prerequisites from there. Okay, this is kind of like preliminary stuff, if that makes sense. But yeah, so we are gonna add it to our visited set, right? The course that we're on, and then we need to check this is where we actually start like backtracking and checking the prerequisites of a specific course that we're on. And the way we're going to do that is we're going to say for prereq in course graph for a particular course, right? right? We're gonna basically run this same function on the prereq, right? And if we're returning false, right, then we return false for the actual function. So basically, we're gonna run the DFS on the prerequisites of a specific course that we're on, and we're only returning really false if there's a cycle, right? So if not, so if we run the DFS function on the actual prereq, right, and we get false, then just return false for the actual function, right? Because the course can't be completed in that case. Okay. Right. Now, after we handle the prerequisites through DFS for a specific course, we can actually remove it from visited, right? Because again, we would just return false if we actually run into any problems. So here we're assuming we didn't run into any problems. Otherwise, we would already exit the function, right? So we're gonna say process.add course, right? Return true. Now, outside of this is where we actually want to run this DFS function on every single course, starting from 0 up to and including num courses -1, right? Because we want to check all courses, if we can finish all courses, right? So we're going to say for course in range num courses, right? We're going to basically say if not DFS course, right? We're going to actually run it on every single course. And if we have a course which is problematic, right? We're going to get false, right? So basically, right, like I'll write now on a comment, right? So if we have like num courses is equal to 3, right, we'd basically have from 0, 1, and 2. So we're gonna run DFS on this, right? And we're gonna basically do all this, and basically run the DFS on the prereqs for that particular node. If we have a problem, we're gonna return false, right? And so down here we would return false also because the actual DFS function would return false. So because the DFS function returned false, it means that we have a cycle, right? In which case we want to return false for the entire class, or not class, but I guess function, the can finish function, because we have a cycle, we can't finish it. Now, if we don't have any problems, we return true because we can take all courses, right? I know I'm kind of wordy. I hope this helped explain things. This video is a little bit long, but I feel like if I kind of skipped over a lot of stuff and just went really fast and made this video like 10 minutes, it'd be a little bit confusing. So I hope this helped. I know I'm just over explaining things so you kind of understand what's happening, but honestly, I don't think this is too hard. As long as you understand like the steps, right? Like remember the steps that I showed you up here, right? It's pretty simple. You're basically setting up the adjacency list, you're setting up the visitor and process node, and then you're running DFS using these things up here. Okay. So again, I don't think it's too hard, but I hope this helped. I think this problem is a little bit confusing, honestly, the first time trying to wrap your head around it. But once you understand like what we're actually doing, it's pretty simple actually. It takes a little bit of time to grasp the problem though, so don't feel too bad. But I hope this helped, and I'll see you in the next one. Peace out.